So let me walk through with you what do this code do. Inside your DSA graph, right, your DSA graph have a search function, this get vertex, right. If you call the get vertex, it's going to loop the linked list until it find the vertex name. Remember just now when I draw the linked list, the linked list, right, have a few items. So example, if the age is 1, right, then the label is going to be 1, the label is going to be 2, 3 and 4, okay. So if you call the get vertex, right, you're going to look for this item. So you're going to loop. So example, if you want to search 3, right, you're going to go through the linked list and get label until you search 3, and then you're going to return that DSA graph vertex, okay. So the DSA graph vertex, right, so I call my variable name. So here is a pseudocode that I wrote to save your time. The DSA graph vertex, right, you're going to call it first to get the relevant position. If you get the relevant position, right, for me, right, I'm not sure if this is a good practice or not, but usually, right, I will declare a boolean outside the loop. Because if you put the boolean inside the loop, right, for me, I think if you initialize it each time, I think it's not efficient. That's why I initialize it in the outside the loop one time first, okay. So also you need to initialize your new destination. This new destination is a string, okay. New destination, just say that's null. So inside the do while loop, right, it's very important you set the resume as true, because if next loop, right, if it's keep resuming when you set it to false, right, I think you can actually put the resume equal true outside here also, but I haven't tested. I think you can, because only when it reach this side, right, this code, this section, only then it will be stopped. So if I show you this code directly, right, it's pointless, okay, it's very pointless. So let me show you example 1, right, I have 2, 3 and 4, right. For example, in 2, right, I have 3, maybe 1, 3 and 4, example, right, and then I have 3, right, I have 1, 2 and 4. Then in 4, right, I have 1, 2 and 3, okay, I have 1, 2 and 3. So how do I make sure, right, I travel from, so example, if I look for a direction from 1 to 2, right, so example, our graph is like this, 1, 2, 3, 4. How do I make sure I get the path one time only without repeating the direction? If you want to know, right, the method I use, and which is taught by my friend doubly, he taught me like this. So you need to have something like holder, okay, some holder. This holder is actually, you can use a linked list also. So this linked list, right, you can actually, if I'm not mistaken, you can call remove insertFirst or insertLast, but for me I just use insertLast because it's just easier, okay. So example, if you want to look at direction from 1, right, so initially our from is 1, and then our to, right, is 2, okay, 1 and 2. This is fixed, don't change this, okay. The from is 1 and the to is 2. So the 2, right, this one is our target. So long the target is not found, right, you are going to continue to loop it. So I give you one example. From 1, right, you're going to pop. What do I mean by pop? If you want to deal with stack, right, pop means remove. If you use the insertFirst, right, if you use insertFirst, then you're going to use removeFirst. So if you use insertLast, right, you're going to use removeLast also, okay, you're going to move removeLast. So long you're able to loop all of this is okay, but this one, right, I just show you first. Visualize, I help you to visualize it like this. So example, if initially you pop 4, right, if you pop 4, then you're going to write the 4 into here. So 4, right, 4 is the destination. In 4, right, you're going to traverse this DSA, right, this DSA get vertex, you're going to get this vertex, okay, going to get this vertex. Then you're going to look at what is the item in here. So you're going to pop 1 time, pop 3. When you pop 1 time, right, you need to check, make sure it's not in from, make sure it's not from, and then you need to check if it's 2. If you find it's 2, right, then you mean this is one path. So if you are not reaching the path, what you're going to do is you're going to record it into a stack. This stack, right? We call this a hybrid stack. Okay, let's call this a hybrid stack. This hybrid stack, right, is from my DSAGraph vertex. My DSAGraph vertex can act like a stack. Okay, remember just now I showed you the diagram of the orange color one. So example, if after you insert 3, right, then you're going to call the recursive function again. So you are going to travel to this destination. Okay, so that it will go to DSAGB again. Get vertex, right? What is the topmost? The top item, right? When you pop it, it becomes 4. You need to check if it's inside this stack. If it's inside this stack, right? If it's inside this stack, then you're going to continue to pop it. So you need to set while loop as true. So you need to continue to pop it. And then, what is the next item? When you pop it, right, this item is 2. So you need to check first. Is it from? It's not from, right? Then you check if it's 2. Okay, it's 2, right? Then you're going to stop. Then you need to record this data. Okay, 2, 3, 4. Record it to a linked list. Okay, the 2, 3, 4 you're going to record it to a linked list. In the orange box, I draw a record 10 path. The record 10 path linked list, right? The record 10 path linked list is going to record this information. Okay, it's going to put 2, 3, 4 inside there. So after that, right, you are not going to stop yet. Okay, so long there's data inside, you are going to continue to pop it. So long there's data inside, going to pop it again. 1. When you pop 1, what happened? It's from, right? If it's from, you are not going to do anything. So if it's the end, right, you're going to check first if the extract, this one, if the DSAGB, right, you call the get edge left. If the get edge right, if the edge left, this edge right. If the edge right left with one item, right, then you're going to enter here. You're going to check it if it's from or not. Is it from or not? If it's from, right, then you're going to remove one level. Okay, you're going to stop it. You're going to set the resume to false. You're going to set the resume to false. Then you're going to remove last. Okay, you are going to remove last because you're going to remove this level. You're going to remove one level. Okay, you're going to remove one level. So initially, after you record this one, right, I forgot to mention to you, when you call the record, right, record item path, right, after you record it, right, when you record it, you will insert here. Initially, our new destination, right, here. New destination. Our new destination is recorded in here. And then when you want to set it, right, when you found the path, right, then you're going to insert the from destination. Where is the from destination? The from destination is in here, in this function. Okay, record valid or not. If it's valid, right, then you're going to set the new destination in here when you set it into here. So it's going to be 1, 2, 3, 4. Okay, sorry, it's going to be 1, 4, 1, 4, 3, 1, 4, 3, 2. It's going to be 1, 4, 3, 2. So you're going to insert first and insert last. After you insert first, insert last, right, you're going to remove first, remove last afterwards. After you add it to the link of valid path, right? Remember just now the orange color box, link of valid path, right? The link of valid path. After you add it, you're going to remove first. You're going to remove first one time. You're going to remove first one time, and then you're going to remove last one time. After you remove first, remove last, right? Then you check here. In the null part, right? If it's not supposed to add into the stack, right, and it's not a valid path in here, right, then you're going to stop and delete one level. What do we mean by stop and delete one level? So if it's delete one level, right, you're going to remove the last part. So you're going to call removeLast again. So you're going to delete 3. So right now, right, your stack is your temp stack, right? Your temp stack is left with 4 only, okay? Left with 4 only. Left with 4 only. So your 4, right, not yet empty, right? Your 4 not yet empty. So you're going to continue to check 2. Is it a valid destination? Yes, we found it. So 2 is a valid destination, right? So we're going to pop it. Then we're going to insertFirst, right? I write it in here, 4. We insert first the original destination, which is from. So we're going to insert the first destination, and we're going to insert last destination into the temp, okay? We insert it to the temp. Then after that, we're going to record to the valid path. After we record to the valid path, then you're going to removeFirst, and then you're going to call removeLast again, and then it will be 4. Then you continue to, the stack will remain as 4. Remain as 4 remaining in here. Then you're going to left with 1 item, right? Then you're going to pop it. When you pop it, right, this 1 is from. This 1 is from, right? Then what happens is you're going to pop 1 time. Pop 1 time, okay? After you pop 1 time, right, then your record temp path will be empty already. Your record temp path will be fully empty. There's no more item to stack. You are going to go back into this direction, okay? This direction. 1 is your from destination. In your from destination, right? So it's going to be something like this. There's a function. Initially, you have a function to get path. In the get path, right? This path is going to look for the 1. The stack of this 1, okay? Going to pop 1 in here. So you're going to call the recursive search inside this function. And then you have 2 functions in total. 2 functions in total. The main recursive function is here. This part, right, this part is only going to do while loop only. Do while to pop it until nothing. So when you call 3, right, when you pop 3, right, you're going to check is 2? If 3 is not 2, right, then you're going to record it to the stack. Then you're going to record it to the stack, okay? Record it to the stack 3. Or record it to the stack, right? Then you're going to go to the position, get position of 3, okay? You get the position of 3. Where's the top one? The top one is 4, okay? You go to the, is the destination in the stack? If the destination is not in the stack, and the destination is not from, destination is not 2, then you're going to record it to the stack. You record it to the stack, then you go to 4, okay? So when you go to this one, right, it's 3. Is 3 is in our record. The 3 is already in our stack record. So if the 3 is in our stack record, right, then you're going to pop it. Okay, let me draw it. You're going to pop it, right? Then you're going to go for this position 2. Is 2 is our target? Yes. If it's in the target, right, you're going to do this. Going to 3, 4, right? You're going to insert first the from. You insert last the 2, then you get another path. After you insert this, right, you're going to put the temp, insert the temp into the valid path. Insert it to the valid path again, okay? After you insert to valid path, right, you're going to removeFirst, removeLast, so the stack remaining as 3, 4. So you can continue go and popping. So you check 1. If 1 is from, right, then you're going to ignore it. When you reach till the end, right, when you reach till the end in here, right, left with 1 item, right, when you check left with 1 item, then you're going to call remove 1 level in here. Remove 1 level. If remove 1 level, right, remove 1 level is simply removeLast, okay? When you remove last, then you're going to remove this one, okay? You're going to remove this one. So we are at 3 now. At 3, right? So what is the next item? The next item is 2. Okay? Is 2 our destination? Yes, excellent. So we are going to record as 3. Then we put 2 and we insert first and insert last. We insert first from. we insert last 2, then we're going to record it to the valid path. After record it to the valid path, right, then you will remove first, remove last, and then the 3, right, going to be in here. Then you're going to continue to pop 1. This one is from, right, this one is from, and because it's the last level, right, because it's in the last level, then you're going to remove it, okay, going to remove it, remove last, okay, remove last. So the stack is fully empty now. After it's fully empty, right, what is the remaining path? The remaining is 2, okay, remaining is 2. So when it's 2, right, what happened? The 2 is the destination, right? So if the 2 in here, if the 2 is the destination, right, you're going to thread record it to here. So it's going to be 1, 2. With that, right, we have covered all paths, okay? We have covered all paths. So this is the algorithm. So let's look at this one. So resume is equal to true, new destination is null. You're going to call the extract, right? The extract, right, is just now what I show you in pop. So if extract not equal to null, right, then you're going to see actually this part, right, this part you can remove it also. I believe there's no chance it's going to be null. You can actually remove this part, but I just add it in case of accident. Actually this one is very not possible. I can't think of the situation you need to check this. So if the new destination, we need to extract and get the name. When you extract, right, you get the name, you get the adjacent name, right? If DSAGraph.getHName left is 1, right? If it's 1, if it's remaining the last item, then you're going to enter here. So example, if it's not the last item, right, it's the top, right, then you're going to, if it's not the last item, right, if it's not the last item, you're going to enter the here. So we enter here, right, you need to check if the destination, right, if it's not from, okay, it's not from, and it is not existed in this tag, right? If it's not existed in this tag, then you're going to enter here. Then hybrid dot record. Your hybrid, right, would be the entire thing to record your item, okay? Java doing things by pass by reference. So if you record this hybrid, right, in here you call the hybrid, right, you initialize the hybrid in here. When you initialize the hybrid in here, right, when you update the data, right, when you update the data, the hybrid in here will also get changes. This is the Java pass by reference. So when you want to make a backup copy, right, in here, later I show you how. For this one, right, when I insert my data, example, when I insert my adjacent, right, I directly insert to 2 positions. One is I insert to the backup edge, okay, I insert to my backup edge. So when I want to restore the data, right, if I check if the edge, right, current value is 0, right, meaning after you finish popping, right, because no matter what we need to finish pop. After you finish popping, so if the count is 0, then only you allow restore edge, okay? So this is my algorithm, okay? Meow trusting algorithm, meow algorithm. So let's call here. If the hybrid, right, is not in the stack, and the hybrid is not existed in the temp, so the temp is this one, the temp is this one, okay? Do you remember in the orange box? The orange box, right, got the linked list called as temp, okay? So it's not from the temp and it's not from n. Then hybrid record the temp path. You record the temp path. So if not hybrid record valid, so you're going to see if it's a valid or not. In this function, right, I check if it's valid or not. If it's not valid, right, so I'm going to put a boolean if this is the same as this destination or not. If it's the same as this destination, right, only then we need to insert first and insert last. Then record it to a valid path. recall it to the valid path, and then only remove first, remove last. Meaning, right, if it's not same, right, it is not equal to this one, you're not going to do anything at all. Just return the boolean, okay? Just return the boolean. Use string dot equals to, okay? Then you're going to search again, okay? Call the recursive function again. Argument remains the same. The argument, right? The argument will be the new destination. New destination is just now we pop above. Just now the one that we pop. New destination. And then the fix, right? Fix from and fix to. Don't change this position. Position is the same, okay? Then you're going to pass the hybrid again, okay? So it's going to keep continue this while loop, right? Until it reach this end. When you reach this end, right? So you're going to check 1. So if it's the 1 is from, right? Example is from the destination, right? It's the from destination. You're going to enter here. What does this do? This, right? This will remove one level, okay? It remove one level. Remember just now I show you it remove one level. Then you're going to set the boolean to false. You're going to return false, okay? This one, right? This one always return false, but inside just have additional function just to remove the last lah. So one function to do 2 tasks, okay? And then after that, right? Let's look at the example. For example, if our this 2. Let's say the end data is 2. Let's say the end data is 2, okay? Let's say the end data is 2. So the fourth condition, right? Fourth condition, if the data is 2, right? So it's going to be enter here. So if it's valid path, right? Then you're going to this one, right? Pass in 3 arguments, okay? New destination, fix from is this one, and then fix to, okay? So if we found the last item is equal to the destination, right? Then you're going to insert first, going to insert last, and then record to valid path. Inside this function, right? I could actually record the valid path, and then I remove first, remove last again, and then I remove. For this one, right? For this one, you only need to remove first and remove last only. Because remove first. Wait a minute. So this one, right? When it's found, right? No matter what, right? You're going to remove first and remove last. One more thing. If it's found directly, right? You are going to stop the loop anyway. You're going to stop the loop. You're not going to continue the loop anymore. So only if the condition, right, you're going to set resume. You're going to set resume is equal to false, and then you're going to stop and remove one level. Okay. In this part, right, you will record insert first, insert last, and then you're going to remove first, remove last, and then in here, right, if it's valid, this one will return a boolean. If it's true, then you're going to remove one level. Okay, remove one level. Else, right? Else if, like example, this is like 3. Example, this is 3, right? You're going to call one more recursive. You're going to call one more recursive. Okay, you're going to call one more recursive. Else, after you finish the recursive, right? No matter what, you have to stop also. So you need to set the resume is equal to false. So this part, right, you have finished already. And for this part, right, you have finished also. If the record, right, if the record not yet end, right, then you're going to continue to pop it. So you're just going to resume, okay? Or even in here, the resume will be false already. When the resume is equal to false, right, when it exits here, right, so you're going to restore the edge. In the restore the edge, right, so you're going to check first. If the edge, right, if the edge, just now the orange box, right, if the edge is count, right, the edge count is 0, then you're going to use an iterator loop, just for loop, okay? Insert last. Okay, with that, we have finished our tutorial. I hope this helped you. I wish you all the best. Bye bye.